Welcome to Marathi ML channel. Today we are going to see the second part of the classification chapter. Those who are watching first time my video, please watch the previous video. As of now, we have covered the two chapter from the hands-on machine learning with Scikit-Learn, Keras and TensorFlow from this book. And I have tried my best to you know explain in very well manner so that you can either watch my video or refer the textbook, but I have given my best to explain in very simplistic manner. So as a part of this chapter, classification chapter, this is the today's agenda, that we are going to see how to do the performance measure of the classification type of problem. So while doing the classification, we can do the same validation technique, that is the cross validation. We have already used this technique in the regression type of problem, and I have explained how the cross validation works in detail. I'm giving a link in this video. You can refer if you are watching this first time. Second is the confusion matrix. This is one of the important matrix for the classification type of problem, and why we need it I will explain in a minute. Let's jump to the notebook so that we can try to learn the things with doing practical code implementation. Now first we are going to see how we can use cross validation score for the classification type of problem. So we know that we are solving the binary type of classification problem where our aim is to predict whether the number which is given in a feature, okay, is equal to 5 or not. If it is 5, then good. If it is not 5, then model is not performing well. So on that basis we are using accuracy as a matrix to check the how my model is working fine, and we are giving cross validation k-fold as a 3, and we have used the edge stochastic gradient classifier for this. And once we did this, we got the almost 95% accuracy. Now everyone is getting happy that we have got the 95% accuracy with this edge classifier, right? And accuracy is the good matrix for our type of model, and we are ready to make the model into this transit the model into the production. But please just stop yourself, and just think twice again before moving any model to the accuracy. For that we are going to do a few tests. What we are going to do, we are going to implement one of the uh, you know one of the simplistic classifier using the base estimator. So for that I'm using sklearn dot base and import base estimator. Okay, this is one of the class we can use if you want to develop your own type of classifier. And what I'm going to do, I'm going to use the never I'm going to develop one custom type of classification model and giving a name as a never-phi classifier. And for that, as this is my child class, so I'm importing my parent class as a base estimator. And now this is a dump classifier, so I'm not using any method, anything as an action for a training. So I'm just overriding the method called fit, and here I'm giving as a self my training data is x, and I'm keeping my y as a none as a default value. And as I do not want to do anything with this, so I'm just keeping as a pass, and I'm going to mention my predict function as a I'll explain how this predict, and I'm passing my x as a training data set. And what I'm going to return, I'm going to return a false values for all the features. So for that I'm using numpy package of numpy zeros, yes, and I'm going to read the length of the my x data, okay, length of the x data, and here I'm passing as a 1 because this is a, I want to make this as a one dimensional. So I'm calculating the length of the x and making them everything as a 0. And for that, as my values become zeros, I'm giving my d type as a false bool, that is false. Whatever, if it is 0 it making false, if it is 1 it will make 1. But as I'm making everything as a 0, so definitely all value become false. Right now, how this classifier works, let me explain you in a minute so that you can understand what I'm trying to say. That, see, we already know that we got the 95% accuracy for our model, but we wanted to test whether the model which we are going to use for a production, is it the accuracy is giving the valid accuracy, or are we getting anything which is really not valid. So for that we have used the fake classifier. What we are going to do here, so whatever x, we know that we have x which columns from 0 to 784. Why 784? Because we have the 784 columns. Okay, and each row contains one digit. So first digit I think 5, second is 0, 1 and 4. Okay, so this is the digit we have. So what we are trying to do here, it is that we are making everything this as a 0 using np0's functionality of numpy. And once it is 0, we have uh, we are making this as a false using the boolean type of data, boolean. So what happened, my x data, my x from 0 to 70,000 row contains everything as a false, right? And my y, which is a y train 5, it contains something as a true, false, false, false or true. So true means wherever there is a phi, it contains true. Wherever there is a f, wherever there is a no phi, it gives the false. So whatever target data contains the digit number phi, it makes the true. So what we are trying to do, that whenever we are passing our data for this classifier, and when now we are not doing any training, so what, when you are passing the data, we are getting the result as a false. Okay, and then after we are comparing this our false data with this our target data set, and let's try to find how my model is accurate with my target data set. Okay, so this is my prediction data, this is my actual. So by doing this, we will get this. So this is my predicted data, right? And this is my actual data, right? So definitely everywhere is false, and here some prediction has a true, someone has a false. So this is what we have right now. So if our model get, now if we get a less number of accuracy, less number of percentage, so we can say that our original model is performing well, right? So let me delete this, let's use the cross validation, and let's see what accuracy we will get. Now we are giving everything is false, so we expect that model accuracy is getting decreased. So I'm giving never, I'm initializing my model, classifier model. So never phi classifier, correct? Then cross validation score. So for the cross validation score, we are passing something called as our dummy classifier, I can say. I'm passing my x data, that is x train. Then I'm passing my target data set, that is y train phi. Yes, I'm using same cross validation as a 3, and I'm using the same matrix that is called as a, sorry, it's a scoring. So I'm using the same same matrix called as a accuracy. Now let's run it and we'll see. Okay, it's a x train scoring is 3. What is the error we have got? Cannot clone the object. You should provide an instance of the, okay, I think so. Let me, yes, this is the correct one. Yeah, so we got almost 91% accuracy. So what this state that, this means that accuracy is not the a perfect, let me take the pencil. This state that accuracy is not the, accuracy is not the correct parameter or correct matrix for any classification type of model. Let me write it properly. So see, even with the, even we are making our all prediction as false. So what we are trying to achieve here, we are making our all prediction as a false. Okay, still we are getting the accuracy as a 91 percentage. So do you say that the accuracy is a good matrix? No, right? Accuracy is not the good matrix. So I can say that accuracy is not always a good matrix for classification. Now the question comes, why it is not, why it is giving a good accuracy though we have made all prediction as a false? The reason is very simple, because we are working with the skewed data set. Why it is skewed data set? Because if you observe the target data set, it contains only 10% of data as a 5 digit, or you can say as a true, right? Only 10% data contains the number 5, rest on contains the other numbers, right? As we were doing the binary classification, and in binary classification we are trying to predict whether that classifier able to predict number 5 or not, but my dataset contains only 10%, so rest of the prediction is a false, right? So definitely, let's say, let me explain you again with very neatly again. Now if you remember, we have, let's say I have the 5 row, 1 2, okay, let me make it this as a something small. Yeah, let me explain you again. So see, we have, let's say, 5 training sample, 1 2 3 4 and 5. Now out of 5 I want to predict, and this is my training data. So let's say this is a true, false, false, false. Yeah, 4, it is a false, right? And my, this is my training data. Okay, this is my predicted data, I can say. This is my predicted data, and this is my actual prediction. Now my actual prediction contain as a true, let's say this is a false, 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 false and true, right? Now with the matrix say accuracy, with the matrix say accuracy, we know that only the one data, actual data, has a true value, remaining is a false. So this is called as a imbalanced data set. So when you are doing the classification type of problem, it is very much important your class should be balanced. So equal number of, now as we are doing the binary classification, so we require equal number of positive, equal number of negative, right? So that model is not the bias. Now this, if you are trying to reduce, so distribution is skewed distribution, right? The distribution of this dataset is very skew, so that even your model try, it always predict the false, and my my target is also contain the 90% as a false and only 10% as a true, and therefore I can say accuracy is not always the good matrix, which is not really explaining whether your model is good or not. Now let's go ahead and try to see if this is the case, then how we can deal with such a situation. Okay, now to deal with such a situation, we can use the confusion matrix. And to use the confusion matrix, what we are going to do, we are using the class called as a cross val predict. So let first I'll write the code, and then I will explain uh, the concept of confusion matrix in detail. So sklearn dot model selection import cross val predict. Yes, and similarly we have cross val score. Similarly we are having cross val predict to get the confusion matrix. Okay, so y train predict, this is what the prediction value, and we can use the cross validation to here predict and giving the HGD classifier as my classifier name, as this is what we are using HGD classifier instance. So X train, this is my train data, and my target data set, my label data set is Y train phi, and I'm using the cross validation phi. So when we do this cross validation predict, okay, let me correct the spelling here, it's yes, okay, so when we run this cross validation, okay, so what we are trying to get, we are getting the prediction, but prediction for each cross validation. Now we have used the phi as a cross validation. Okay, so it's okay, but let me use, so it will take less time, let me change it to the 3 just to make it faster. Okay, so what we are getting, so when I say cross validation predict, so what it is trying to, so as I already explained the concept of cross validation, sorry, let me make it small. Yeah, so as I explained, when I say cross validation 3, so it contains the three uh, three folds. Okay, so three folds, so it will dividing our training data set into the three fold, right? So one fold is the test and remaining one is the train, and this will happen iteratively 3 times. So first time this is a test data set, second time this will be the test data set, third time this will be the test data set, right? So this way it will try, and every time it will collect the prediction on this y train predict. Okay, always it will collect the in y train predict, correct? Now once we have this, let's calculate the confusion matrix. So to calculate the confusion matrix, we are using the Scikit-Learn package dot matrix import confusion matrix. So in the confusion matrix, to calculate the confusion matrix, we must have to provide two things. Okay, so first we wanted to give the actual prediction. So actual prediction is y train phi, and the predicted prediction is a y train, actual value is y train phi and predicted y train pred. So when we run this, we will get this kind of matrix. So let me spend some amount of time here. So if you see, it's a binary classifier, okay, and this contain this way. Okay, so before before this, let me show you the picture first, and that will be make your work, make the things easy for you. So let me, yeah, let me paste the picture here so that it will make, it will be very easy to understand the, yes, 1 second. Yeah, so here it is a picture. So this is what the confusion matrix look like. So if you look at this, let me take the pencil. Yeah, if you look at this, this is my actual value, this is my predicted value. What we are trying to say, this is my negative prediction, this is my positive. Negative means not phi. Okay, my model say this is a not phi, and positive means my model says this is a, it is a phi. Okay, similarly my actual says this is a not phi and my positive says this is a 5. Now if you look at this thing, the actual contains the value is the actual value is 8, 3, 9, 7 and 2. So definitely it's not 5, definite, so I can say this is a negative value, and my model is also saying this is a negative value, means it doesn't contain the 5. So this is called as a true negative. So this is called as a true negative. So in my array, if you say 53,892 values are the true negative, these are the true negative. It means, why, what is the meaning of true negative? My model says it doesn't contain 5, and actually also it doesn't contain. So value of this is a true negative. Similarly, now if you look at this positive, so my model says 6 is a not 5, but my not model, so actual value is say it's a 6. Actually it doesn't contain, sorry, my bad. So actual value is not 5, but my model says it is a 5. So this is called as a false positive. So what is the meaning of false positive? Model predicting the value as a 5, but actually it is not 5. Okay, model predicted as a positive, but actually it's negative, so it is called as a false positive. So almost 687 values my model predicted as a false positive. Similarly, this is called as a false negative. Why it is false negative? Actual these are contains the 5, actually these are 5, but my model predicted as a negative. See, my model predicted as a negative, so these are called as a false negative. Whenever there is a wrong prediction, okay, negative prediction, then it, but which is actually positive, then this is called as a false negative. So almost 1891 values are the false negative. Similarly, there are called as a positive. Actual is positive, and my model also predicted as positive. This is called as a true positive. So this is how many true positives are 3530. So in a nutshell, we always try to develop the model which are giving true negative and true positive. We always focus on this number and try to reduce this false positive and false negative. Right? Understood? So we always try to reduce this false positive and false negative. So this is what is called as a confusion matrix. Though it is confusing, but if you understand thoroughly with this example, you can easily understand what do you mean by false positive and with the false negative. Now there is a one more concept called as a precision and recall. Now if you want to get this, now we can understand, but if you really wanted to get this through code, you can also easily get through the code. If it is a binary classifier, then this is something called as a, you have to just give the ravel as a function name, then it will give how many are true negative and how many are false positive, just to clarify. So see, we predicted these are the true negative, false positive, false negative and true positive. Okay, so we always focus on these number, true negative and true positive, and try to reduce false positive and false negative. Now there is a one more concept called as the precision and recall. Now before that, okay, before that, let's say whether this confusion matrix is good, correct or not. Okay, so what type of model we are trying to see? We are trying to, so let me make it one thing here. Okay, so what we are trying to say, we are making our all prediction as a actual one, and let's see how the confusion matrix look like. See, when you are making all actual as a prediction, it is giving 0 as a true negative, sorry, false negative and false positive. See what I am trying to do, I just giving actual as a prediction. So this type of model where, but in reality this is difficult, but this is what we are trying to say. Let me jump to the last topic of precision and recall. So what is the precision? Precision is nothing but the, I'll definitely explain in next video in detail, but just to give a hint, what is precision? The precision is the accuracy of positive prediction. Accuracy of, okay, let me show you in the diagram, that will be very easy. Yeah. So precision is the, yeah, so this is called as a precision. So what is precision means? It's a accuracy of positive prediction. Accuracy of positive prediction. What does mean that? Accuracy of positive prediction means that if you look at this, the formula is TP upon TP plus FP. TP upon, so how many, so out of positive prediction, this is what, a positive. If you look at the predicted as a positive, so these are the positive prediction. Out of positive prediction, how many actual are positive, this is called as a precision. So out of 4, only 3 are actually predicted as a, so out of 4 positive prediction, out of 4 positive prediction, only 3 are actual a positive, this is called as a precision. And second is the recall. So what do you mean by recall? Recall is this. If you look at this row, so recall is, this is also called as a true positive rate. What do you mean by true positive? From actual positive, that is TP plus FN. From actual positive, how many predicted as a positive? From actual positive, how many predicted as a positive? This is called as a recall. So we always try to make a model which is a balance between the precision and recall for the good model, but this is not the always case. Sometimes precisions are more important or sometimes recall is more important. It is differ based on model to model. So in a nutshell, I can say that if the data, if your data set is a skewed data set, accuracy is not a good matrix. You have to look for the other matrix, say precision and recall or F1 score. In coming lecture, we will see what is a precision and recall once again, but I have already given you the basic things, and also we will see the trade-off between the precision and recall. I hope you like my explanation. If you like, please like this video, subscribe and share as much as possible. Thank you.